Hello everyone, my name is Priya Pai. I am finally a student pursuing my BE in the stream of Electronics and Communication Engineering at PACE Institute of Technology and Management, Shimoga. I am here to present internship project on microwave oven simulation. This is the final project submission of embedded system offered by MX Information Technology. In this presentation, I present PPT on what I have learnt during my internship period, and next I will show the implementation of the project. Table of contents. In table of content we can see what is microwave oven, modes of microwave oven, what is embedded system, types of embedded system, examples of embedded system, microcontroller and microprocessor, requirements. PICSIM lab, CLCD, matrix keypad, interrupt service routing, which is nothing but ISR, timer, and at last project implementation, the demo of the project. The topics that are covered during the internships, which can be seen the list of topics that are covered are Introduction to C, conditionals, loops, and operations, data structures such as arrays, pointers, functions, and strings, storage classes, functions and strings, introduction to embedded C, introduction to systems and microcontroller, MP Lab, IDE, XC8, PICSIM Lab, introduction to various peripherals of PIC16, F8, 77A, peripheral programming, interfacing various peripherals of PIC16F977A, and at last the project implementation. What is microwave oven? A microwave is an electric oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range. There are several modes in various microwave ovens. In this project, we are going to implement 4 modes. They are first one, micro mode, second one, grill mode, third one, convection mode, and fourth one, start mode. Modes of microwave oven. First one, micro mode. The most basic type of microwave oven is micro mode. This mode is used to cook food in traditional way such as defrosting, cooking, reheating. It uses maximum power of 900 watt. Second one, grill mode. This microwave oven is improvement over the micro mode. This mode can grill food such as meat and bread in addition to performing all of the usual functions of microwave oven. Third one, convection mode. A convection mode has a fan and exhaust system that a regular oven does not. The fan and exhaust help to blow hot oven air over and around the food. In other words, it preheats the food for a particular temperature. It cooks the food evenly and more quickly. 180 degrees Celsius is the set temperature for baking. Fourth one, start mode. It is the default mode whenever the user presses the start button of microwave oven. In this mode, the timer is set automatically to 30 seconds. Next, what is embedded system? Embedded system is a microprocessor or a microcontroller based smart system. Combinations of any hardware and a software which is designed to perform a set of specific tasks. A general purpose system is used to perform a large number of tasks, whereas an embedded system is used to do a specific task. Types of embedded system are: first one, standalone system; second one, real time system; third one, network system; fourth one, mobile system. This shows the figure of types of embedded systems that we can see. The first one is standalone, second one is real time, where real time are again classified as soft and hard, third one is network, and fourth one is mobile system. Let us know these four types of system in briefly. First one, standalone system. This is a application or a software that does not need to be bundled with the other software or applications. In other words, it can stand on its own without the help of internet or another processor computer. Instruments like cameras, digital watches, and MP3 players are all examples. They work by themselves without relying on larger platform. Second one, real-time system. This kind of embedded software needs to deliver outputs promptly within a particular time frame. Real-time embedded system can be further broken down into soft and hard categories. Some examples of real-time embedded systems are aircraft or autonomous vehicle controls, traffic monitoring tools. Third one, network system. This type of embedded system relies on wired or wireless networks for output generation. Systems which are connected to network are called network system. The most popular examples of network embedded systems are home or office security system, point of sale tools, and ATMs. Fourth one, mobile system. Mobile embedded systems are those that are portable and easy to move around. A mobile operating system is a software that allows smartphones, tablets, and other devices to run applications and programs. Here the example for mobile system is robot. We can see different examples related to embedded systems. Some of the examples which can be seen in the figure that are camera, smartphone, mobile phone, car, printer, televisions, and so on. The difference between microcontroller and the microprocessor. Microcontroller are widely used in embedded system. Microprocessor are widely used in computer system. Microcontroller has a CPU, a fixed amount of RAM, ROM, and other peripherals all embedded on it. In microprocessor, it has only a CPU embedded into it. Microcontroller, the size is small. In microprocessor, size is large and complex. Microcontroller consumes less power. Microprocessor consumes more power. Microcontroller has inbuilt timer. Microprocessor don't have inbuilt timer. Microcontroller have serial port. Microprocessor don't have serial port. In microcontroller, it has separate memory to store program and data. In microprocessor, program and data are stored in the same memory. Microcontroller input output ports are available. In microprocessor, input output ports are not available. The requirements. In requirements we can see MPLAB IDE, XC8 compiler, PICSIMLab, PIC16F8, 77A, 16.4 CLCD, tactile switch, matrix keypad, timer, and at last fan mode. Here we can see the PICSIMLab architecture where PIC16F8 77A are connected to various buzzer, digital keypad, matrix keypad, CLCD and so on. The connection can be seen in this figure. The next is PIC16F8 77A. It has 40 pins. It has 5 ports in total. Port A, Port B, Port C, Port D and Port E. It supports serial communication for which it has 2 pins, that is transmitter and receiver. You can receive the data from RX and can transmit data from TX. Need to upload hex file while in PIC16F8 77A. CLCD, which is nothing but character liquid crystal display. In short, it is called as CLCD. In PICSIMLab, there are 2 types of display: 16x2 display, 16x4 display. It displays the ASCII character and some special character. 2 types of communication mode can be seen in CLCD, that is 4-bit mode and 8-bit mode. Tactile switch. Tactile switch is a switch whose operation are perceptible by touch. This switch is used to select the mode of operation, to enter the temperature and to enter the time in our project. This switch will produce a bouncing effect when a switch is pressed. There is a metal plate and a terminal. Matrix keypad. This is a keypad in which number of tactile switches are connected in row and column concept. This is used when more number of users inputs are required and still want to save some controller input-output lines. These keypads are most commonly used in telephones, calculators, and digital lockers, etc. In the cooking mode, the matrix keypad keys are used to select the respective modes. Here, the first figure shows the front keypad and the second figure shows the back of the keypad. ISR. ISR is the short form of interrupt service routine. An ISR is branched subroutine that is invoked by hardware in response to interrupt. When ISR ends, the interrupt flag is cleared and the code executions returns to the saved register addresses. It must be terminated by RET. When an interrupt occurs, the MP first executes ISR before any other piece of code. Timer. Timer is an important application in any embedded system, which is default peripheral which maintains the timing of an operation in synchronous with a system clock or an external clock. It has many applications such as measuring time and generating delays, etc. Timers or counters are softwares designed to count the time intervals between the events. Resolution, which is also called as register width, 8 or 16-bit, and so on. Tick is referred to as a change from one number to another number. It may be an up counter or down counter. And last, fan mode. As implied by the name, cooling fan module is a device in a car that controls the temperature in the engine by regulating the speeds at which the fan motor rotates. This creates a cooling effect in the engine by preventing it from overheating. Next is project demonstration. This is Pixim Lab software. Here I am going to simulate microwave oven. I have chosen microcontroller PIC16F877A. I have chosen PIC Genius board. After selecting this, I have loaded the project file while I have already saved. The file which I saved using MPLAB IDE software, I have uploaded that file in it already. Here the file is loading. After loading the file, it shows powering on microwave oven. After that, now it's showing 4 mode of microwave oven. We can see that 4 mode of microwave oven in this display screen. First one is micro mode, and here the second one is grill mode. Third one is convection mode, and the fourth one is start mode. To select a micro mode, we should press 1, and to select grill mode, we should press 2, and to select convection mode, we should press 3. To select start mode, we should press the button 4. First we will select micro mode. To select the micro mode, I have pressed on the switch 1. This micro mode shows that it has consumed the power 900 watt. Here the display shows the user to enter the time required to cook the food. The time required to cook the food means we have to set the time first. Let me set the time for 10 seconds for our convenience. Here star is to clear and hash is to enter the time. To start the timer, we have to press hash. Relays act as switching on or off button of the device. As I have pressed hash, the timer is running and the cooker is started cooking the food. Here we can see that 4 is to start or to resume, 5 to pause, 6 to stop. Here we can see the cooler is turned on, which indicate the timer is on, and the buzzer is turned on. This also indicates that timer is on. The cooler will cool the microwave oven. It removes the heat from the microwave oven. After the timer stops, in CLCD display it shows that cooking time is up. After that, the buzzer will turn on, indicating that the timer is off. To turn on the grill mode, we have to press 2. It is working similar to micro mode. It asks me to enter the time. Let us set the time for 20 seconds. The same procedure as the micro mode we can see here. The star is to clear and hash is to enter. And the fourth one is start, resume. Fifth one is pause. Sixth one is stop. And the fan has turned on to cool the microwave oven. To pause the timer, we have to press 5. Now I am going to press 5 here. We can see that the timer is paused at 13 seconds. To resume the timer, here I am going to press 4. We can see that the timer is started again. Of the timer has been paused. To increase the timer, we can press 4 again. Here the timer has increased to 30 seconds that we can observe in CLCD display. It's running now. And to stop the timer, we have to press 6. I have pressed 6 here. You can observe that the timer is stopped now. Okay. Let's move on to the second mode of microwave oven, that is convection mode. For that, we have to press 3. Now let's press on the button 3 to get the convection mode. It asks me for the temperature for preheating. We can set temperature up to 255 degrees Celsius. Now I enter 275 degrees Celsius. Point to start is press hash. It's shown in is showing that enter valid temperature. As the temperature we pressed was 275 degrees Celsius, which is more than 255 degrees Celsius, so the buzzer sound become on, indicating to enter a valid number. Now I will press a valid number, that is below 255 degrees Celsius. Let us set 125 degrees Celsius. I am going to start by pressing hash. The preheating is started. Here the preheating time we can see is 180 degrees Celsius. Let's see about this. Here this is the matrix keypad. And this one is LED. These are processor, and this one is the cooler module. The display which we display the data is CLCD display. As we know, reset button act as restart the simulation. LEDs are the indicator. Cooler will help to cool the microwave oven. Registers shows whether the door has opened or not of the microwave oven. 2 timers will be used, as there are 2 timers in microwave, but we are using timer 2. Let me fast forward this as the timer is running. Okay. Now let's see fourth mode of microwave oven. The fourth mode of microwave oven is start mode. Now I set the time for 10 seconds. Here we can see in start mode the timer has automatically set for 30 seconds. And the same operations, the fan is rotating to cool the microwave oven, and the buzzer will turned on to indicate the timer. Applications of the microwave ovens are reheating and cooking, disinfecting kitchen items, making citrus fruit juices, heating beauty products, roasting garlic, decrystallizing honey. We can see the advantages and disadvantages of this microwave ovens. Like advantages: fast volumetric heating, higher drying rate, short drying rate, enhanced quality of the product, reduced energy consumption, lower operating cost. And the limitations of this are high initial cost for industrial scale dryers, partial loss of aroma, and negative sensory changes. Product texture may be affected. Specific sample size and shape may be required for effective drying. As conducting this project, we came to conclusion that microwave ovens heat food using microwaves, a form of electromagnetic radiation. Similar to radio waves, microwaves have three characteristics that allow them to be used in cooking. They are reflected by metal, they pass through glass, paper, plastic, and similar materials, and they are absorbed by food. Microwave oven will update along with the advancement of technology and its future uses. Thank you for giving this opportunity. Thank you, Emertxe Infotech, for giving this wonderful opportunity, and it's a good platform to learn new things. Now the cooking timer. The food is also turned off. This is the overall implementation of the four modes of a microwave oven, which we have seen one by one. That's all I wanted to say about this project. Thank you.